now. So the kind of force that is occurring between A and D is a repulsion force. That's why here this force is like taking the particle D away from A. Okay, that's why you see the force that is acting in that way. Now, what happens here? According to Coulomb's law, I need to know the distance between the particles. I don't know the distance between A and D. Okay? I don't know the distance. Take a look. I know that I have this distance here, and I know that I have this other distance right there, but I don't know the exact distance between them. I mean, this distance that separates the two particles, I don't know it. Okay? And because I don't know it, I have to get it. Now, if you notice, I mentioned a few things. For example, I know the distance between A and D. I know the vertical distance between A and D. Vertically, they are separated by 5 meters. Okay? So here, the distance is going to be 5 meters. Okay? Now, I also know the horizontal distance between A and D. Between A and D, I have this horizontal distance, which is 8 meters. If I just take this apart, I'm going to have a rectangle, a triangle, okay? So if I just take that triangle apart, I'm going to have this. I'm going to have my vertical distance, which is 5 meters, and I'm going to have my horizontal distance, that is 8 meters. And I want to know what is the distance between the particle A, which is here, and the particle D that is placed over there. Okay? I want to know what distance this makes. So, how or what formula I have to use to get that distance?
We can use the formula of the hypotenuse.
Exactly, we can use the formula for the hypotenuse. The reason is because we have a right triangle. It's a right triangle because here we have an angle of 90 degrees. Okay? So I think that this part is equal to the distance between A and D. Okay? So I say that this works like a hypotenuse. If it works like a hypotenuse, I can use the equation. I mean, I can use the formula for the Pythagorean theorem. So that formula is going to be distance between A and D is equal to the square root of, okay, the two sides, okay, 5 meters raised to the second power plus 8 meters also to the second power. How much is this? Well, this is equal to square root of 89 meters to the second power. This is equal to how much?
9.4.
9.44.
4.
And these are meters. Okay, these are meters. Now, it is also important that we get this angle. The angle is important, okay? So I want to know what this angle is. According to the formulas that we use, how can we get that angle? What is the formula that we use in the components table to get the angle? Angle is equal to what? Okay, angle is equal to arctangent, okay, of y over x. In this case, y is the vertical side, which is the opposite, okay? That's the opposite, and that's the vertical side, divided by the horizontal side, which is touching the angle, so it is the adjacent side. So we say that the angle is equal to arctangent of opposite, which is 5 meters, divided by the adjacent, that is 8 meters. You cancel meters with meters, and what is the angle that you get from this?
42.
32 degrees. This is important. Okay, this is important. So I'm going to my schedule here, my sketch over there, here, and I will locate the angle right here. My angle, which is 32 degrees. That's important. And I know that my distance here between the particles is 9.44 meters. Okay, that is important. Now, knowing the distance between the particles and knowing that I have two protons, I can get the electric force by applying Coulomb's law. So right now I'm going to apply Coulomb's law for AD. Okay, so I'm going to say force AD is equal to, and I will apply the formula. Okay, it's equal to Kc times the charge A times the charge B divided by the distance between A and D raised to the second power. I substitute by the givens. I'm this level of lazy, I'm just going to copy and paste from this. Because I have two protons, the two charges are going to be positive. And the distance between the particles is different, so I'm going to change it. What is the answer that you get when you apply these formulas?
2.58 times 10 to the negative 30 power.
2.58 times 10 to the negative 30 power. These are in newtons. Now, with this, we complete the diagram of the particle D, because now we know the force AD, okay? But take a look, because this force is inclined, okay, it's at an angle, we need to indicate the direction of the force. Now, how can we get, I know that the angle, okay, I know this angle, but this angle is between the particles AD, okay? Now I want to know the angle of the force. So for this, what I do is I take a principle for a geometry that says, this principle in geometry says that angles are transmitted to the opposite corners, okay? So angles that are located in opposite corners are going to be the same. Yes, that is the answer, 2.58 times 10 to the negative 30. Okay, so take a look to what we're gonna be doing. As I was saying before, there is a rule in geometry that says that angles are transmitted to the opposite corner. That means that this angle of 32 degrees is going to be the same angle here, okay? The two angles are going to be the same. It's like a mirror, okay? Now, this angle of 32 degrees is going to affect my force AD. In other words, my force AD, because it is applied at an angle, it's going to have components. Okay, in this point, I want you to tell me if you are following me. If you are following it, what we're doing. Do you understand how I got the 9.44? Do you understand how I got the angle? Do you understand why the angle is transmitted here? I don't remember the name of the rule that we follow in geometry. I just know that, I just know that. Um, for example, if I have a rectangle, for example, if I have a rectangle, here you can actually see it. This is my this is my right angle, and as you can see, it's a mirror from the other side. Okay, so this tiny portion here is the same tiny portion there. So that's what we know as transmission of angles. So take a look to what we're doing here. The angle is being transmitted to the other side, and that tells me that in the end, the force AD is going to have components, and that is important. I'm gonna move this. I'm gonna do this a little bit bigger. Okay, so I have my force over there, and I have to get the components of that force, okay? This force is coming from the origin of the particle, more or less from here. So this force, which has an angle, is going to have components. One component is going to be over the x-axis, and it's going to be the component in x. And the other component is going to be vertical, and this one is going to be just the component in y, okay? These are fx for AD, and this is fy for also AD. Okay. I know that it looks very messy. Okay, I know it. I know it. So what I do now, because it's very messy in this moment, what I'm gonna do now is I'm going to make the sketch apart, and then I will work with this. Okay, I do again my sketch, but I focus only in the particle D. Okay, I will focus only on the particle D. And this is everything I have, this is everything I have. So what I do is, because I have, how many forces I have here in total? I have the force BD, DC, DE, and AD. In total, I have 4 forces. So I'm going to place it here in the table of the vectors. Okay? So I'm going to place it here in the table of the vectors. Here I'm going to place the force BD. Here I'm going to place the force DC. Here DE, sorry. And in this one, it's going to be AD. Now I will locate all the forces, and I will put all the information I need. Okay, so here I have the vectors, okay? So this is my force BD, this is my force DC, this is my force DE, and this is my force AD. And I will put all the rest of the information I need. So for BD, I know it's negative 3.6 times 10 to a negative 30. But here in the table of the vectors, I don't write the number. I don't write the sign, I just write the number. So this is 3.6 times 10 to a negative 30 Newton. DC, which is negative 9.2 times 10 to a negative 30 Newton. DE, that is 2.84 times 10 to a negative 30 Newton. And AD, which is the last one that we got, that is 2.58 times 10 to a negative 30 Newton. Okay, so I place all the values in all the vectors. Now let's focus on the components. Remember this, in the x component, we are going to consider that this side to the right is positive and this side which goes to the left is going to be negative. And for the y component, we are going to consider that if it goes up, it's positive, and that if it comes down, it's going to be negative. Okay? Now take a look to the first vector. The first vector is just moving horizontally. That means that it's only acting on the x component. It's not moving vertically, which means that the y component is 0. So you don't need to do anything here. In DC, it's just moving vertically, so the x component is 0. In DE, it's just moving horizontally, so the y component is 0. But here, for AD, it has an angle. It has an angle, okay? This angle is 32 degrees. That makes that this vector actually has components. So this is going to be your x component, and this is going to be your y component. Take a look. The y component is in front of the angle, so it's going to be opposite. If it's opposite, it's sine. So here you will get your fx, and here you will get your fy. So fx is according to the angle. Fx is the angle, okay? Touching the angle. Therefore, if it's touching the angle, you're gonna be using cosine of the angle. For Fy, are you following me here? For Fy, I know, así no era. For Fy, which is in front of the angle, okay? Fy is in front of the angle. If it is in front, is opposite. If it's opposite, is sine. If it's in front, is opposite, and if it's opposite, is sine of the angle. So what are you going to do as a homework? As a homework, you're going to complete this table of components, okay? You're going to write a component of the vector where it corresponds, and you're going to write the sign where it goes. For example, the first one, BD, it's going to the left. So the x component is going to be how? Positive or negative?
Negative.
It's going to be negative. Okay, so you will complete this table because we're going to continue with this exercise on Friday. Yes, I know it's a long process, but remember I must do it with you. Now, what happens in the last part? Here, nothing, because those are the only vectors that we have. But then remember that you have to add everything vertically. I mean, here all the x components, okay, you're gonna place them there. And here all the y components. You're gonna add all the numbers that you have here. You're gonna place them here. Once you have everything, you will get your resultant and your angle. And once you are done with that, I will continue on Friday by doing the sketch of the resultant electric force. So as you can see, this process is the same process that we did last year. The only difference is that last year the forces were given, but now we're getting the forces, and they're not regular forces. They are electric forces. That means that we need to use Coulomb's law. That's why it's different. But the rest of the exercise is the same that we did last year. Also, this part is like the tricky part of the exercise because the distance is not given, so you have to get it by using the hypotenuse formula. And also you need the angle, and then you need to transmit the angle to the opposite corner. Okay, so those things are things that you must consider for these exercises. That will be it for today, and I'll see you on Friday to discuss the rest of the exercise.